So first of all, I'd like to give a short introduction about Dr. Lev Manovich, and after that, Dr. Manovich will give us about like 40 minutes talk. After that, there will be a Q&A section. Dr. Lev Manovich is one of the leading theorists of digital culture worldwide and a pioneer in the application of data science for analysis of contemporary culture. Manovich is the author and editor of 15 books, including Cultural Analytics, AI Aesthetics, Theories of Software Culture, Instagram and Contemporary Image, Software Text Command, Soft Cinema Navigating the Database, and the Language of New Media, which was described as the most suggestive and broad-ranging media history since Marshall McLuhan. He was included in the list of 25 people shaping the future of design in 2013 and the list of 50 most interesting people building the future in 2014. Manovich is a presidential professor at the Graduate Center, CUNY, and the director of Cultural Analytics Lab. The lab created projects for Museum of Modern Art, NYC, New York Public Library, Google, and other clients. Manovich's latest book, Cultural Analytics, is being published by the MIT Press in fall 2020. So it's our honor to have you to present today. Also, thank you, Tianjing, for the help organizing this event. So let's applause to welcome Dr. Manovich. Thank you.
The applause was not so strong, but okay. Thank you so much for inviting me. I'm spending lots of time in South Korea. In fact, already been here for a year because once my university moved all the classes online, my wife she's a musician and theater person from South Korea, so we immediately came here. And I'm hoping to stay here for a while until I have to go back to New York. I prefer, these days I prefer Korea or any Asian country to America for obvious reasons. So maybe I'll be able to visit Hong Kong. I know many people at different universities and also in the arts. So let me share the screen and start the talk. Okay, actually, here we go. Yeah. Okay. Oh, what's happened here? Oh, sorry. The slide should go first. Okay. Okay. And thank you for very beautiful poster. I collect this poster, so it's very, very nice. Thank you. So this is the cover of my latest book. It came out in October, but I'm not going to simply kind of narrate some points from the book or summarize them. In fact, I'm going to go further because as I was working on cultural analytics for about 15 years, which resulted in a new book. In the beginning, I was extremely enthusiastic about the use of artificial intelligence and data science as a new tool to analyze culture and society. That was 2005, 2007. But the last few years, after about 10 years of doing it, and I kind of moved, I was a professor of art at the University of California, San Diego. And then I actually, 10 years ago, I didn't know how to analyze data. I didn't even know how to use Excel. So I taught myself. And when I was invited to become professor of computer science at the Graduate Center CUNY, I never took a single computer science class in my life, but I was programming since the age of 15. And as many digital artists, we had to program in the beginning because the GUI interface, the GUI software didn't exist. So, as you can see, I got very deeply involved. So spending more and more time, right, inside data science and reading thousands of papers where computer scientists apply data science methods, machine learning to cultural and social data, I started to wonder, right, about deep assumptions of our field and also question my own work and come up with certain challenging questions. And this is what I will talk about today. Now that this field is established, there are hundreds of thousands of interesting papers. Where can we go next? So these are some with challenges. How we can use big cultural data or big social data without aggregation and summarization. Both traditional statistics in data science are based on aggregation and summarization, something which is not frequent, we throw it away. But is this the right way to represent and understand society and culture? How can computers help us to think without categories or without traditional categories? Right. So supervised machine learning, which has become a major way in kind of how a society thinks, right? Typically uh, assumes that you train a network, right? By giving lots of examples which fit into particular categories, which we take for granted. Often these categories are used unquestioned. We take them from society and culture, which means we can represent, we repeat, right? We repeat the traditional way of thinking. So maybe that's a problem. So how can we learn from computers to understand the world differently? For me, computer is a kind of alien, right? It offers us opportunity to question our thinking, to question our categories, to question our beliefs, as opposed to always teaching computer to think like we. In machine learning, maybe we should use computers sometimes for machine unlearning, right? To help us unlearn what we know. Uh, and finally, how to work with big data without using numbers. Is it possible? Well, it turns out that with visual images and visual media, it is actually possible. We can work with big data without quantifying it. So I hope this is challenging enough for you. So let me now try to explain these ideas in more detail. This is, by the way, you read my biography. I very much appreciate it, but maybe it's interesting also for students to know a bit more about me. I mean, how is it possible that somebody was professor of digital art and then becomes professor of computer science? Uh, so I studied many things, but this is a different kind of biography, which is more important uh, because this cultural analytics project, in a way, it's been a project of my whole life, right? And it took me a long, long time to realize what computers can do, right? So as a child, I started art lessons and got professional art training. In high school in Moscow during communist time, we started to learn computer programming, uh, right? So at the age of 18, I was a first-year student in the architecture school. I got obsessed with semiotics and psychology of art. And I asked myself, so how are the cultural images structured? How are we organized? How we communicate? I mean, why some images are better than other images? How images express emotions? Right? And then in '84, after moving to America, I started to work in computer graphics, computer animation. There's maybe only 40 to 50 people in the world at the time who were working in this field, so it was very exciting. And then I started a PhD program in experimental psychology. And while I was learning it, I was very lucky to take a few classes in computer vision very early, right, in '86. And then I spent the '90s, right, in the first part of 2000, about 15 years, developing kind of theories of new media, digital culture. So thinking how we can describe digital culture, right? What are the new terms, new concepts, new dimensions we need to talk about. And that was very exciting. But I'm a kind of person, I like to start new fields, right? Or I like to be in the beginning. I like to get into the field when there is like maybe 20 people in it, right? Or 10 people. So you don't have to read always millions of papers and quote them, right? Because there's nothing written about it yet. And once the field becomes very developed, I kind of do something else, right? So I was very lucky to do it already 3 times. And now with Cultural Analytics book is published, I'm trying to start a 4th field. Uh, Anyways, in 2005, right, the computers have become fast enough to process thousands and millions of images. And I thought, well, it's very difficult to understand how a single image creates meaning and how a single image communicates. But maybe I can approach this problem from a different point of view and start analyzing millions of images to understand the patterns and structures in contemporary visual culture and also in history of art, history of cinema, but also contemporary things like music videos, posters, anime, all kinds of visual culture. And then I established the lab, and after about 10 years of working, we did about 45 projects, and then I thought, now I know enough, so I can share my experience, and I wrote this book. Okay, so today, data science, right, is used in literally, right, many areas to analyze contemporary culture, but perhaps what's most important is that what I call kind of cultural analytics, right, in fact, has become new foundation of contemporary culture media. Right? And by cultural analytics, in this case, I mean the use of computers to process, analyze big cultural data, and then this analysis is used to offer different services. So, for example, right, web search, Google or so on, based on analysis of content, right, and metadata of billions of pages. I mean, Google image search, it's also based on analysis, right, of billions of images. Recommendation systems, right, what we get in Netflix, Amazon, and I'm sorry for using kind of Western examples. I mean, of course, the same services exist in different platforms, right? TikTok, as we know, right, has been described as the social media, social platform, which specifically became very big and very popular because of its very sophisticated use of AI. Right? So, of course, people still make paintings and people still write books, but to the extent that we use computer as a kind of interface, right, to bookstores, to collections of movies, to social media, right, what we see, right, what we see on our media streams, what we recommend, and so on, what images we see when we type something in image search is basically based on analytics. Right? So this is why I think that today people interested in culture have to learn, right, a bit of data science, a bit of computer vision, a bit of natural language processing, and so on, simply to understand how contemporary culture works. And it also means that we researchers in social science and humanities should also learn these methods. Why these methods are only used in the industry, we can also use these methods to study culture and society in new ways. Yeah? Uh, so in the last few years, there has been academic attention to this idea of cultural analytics, the use of computational methods to study culture in large scale. Some colleagues established a journal of cultural analytics. There are conferences, workshops, and even job positions. And in my case, I'm reading very widely because this work can appear in many different fields, right? In AI, in media computing, in computer vision, in sociology, in psychology, and so on. And this is just examples of, of particular papers I like. So you can see that these methods I used to study kind of cultural history, diffusion of trends and cultural concepts in Facebook photographs, asking what people wear worldwide, looking at the variability in popular music. There's a whole area now, right, of people applying computational methods to analysis of fashion and also looking at art. And I'll just show briefly examples of a couple of these papers for those of you, for maybe students who never encountered this research, because as I said, right, it's a bit, this research is everywhere, but it's a bit hard to talk about it because it actually doesn't have one name, right? So I use cultural analytics as this umbrella term, but in reality, it can appear lots of places. So again, the next two things I'm going to show, It's not my work, just to be clear. So this was a project by New York Times, right, a couple of years ago. So what we did is we wanted to look at popular songs, the songs which got into a Billboard 100 list every summer in America for 30, 40 years. And we downloaded the data for the songs from Spotify. So Spotify, right, has about 40 million songs in this database, and every song is analyzed, and they extract about 14 different parameters, 14 different features, and then we kind of build this more, high-level features, right? So we analyze things, and then we come up with things like danceability, acousticness, energy. So New York Times designers, right, have used 5 features. Even every song can be drawn as this kind of shape in a 5-dimensional space, right? So very, very, very easy, very smart. And then what you can do is you can draw the shapes for all the songs which were popular in the summer of a particular year, right? So here we see selection from 1987 to 2012. And even visually, you can see that in some years, the songs were more similar, right? Because all the shapes are kind of closer together. In other years, the songs are more different on these five parameters, 5 dimensions, because the shapes, are more diverse. But sometimes, right, our eyes don't tell us things correctly, so we kind of colorize it to make it clear. So I think here, right, we can see maybe 99 things are very different, and then 2010, 2011 things are very similar. And I mean, it's a very beautiful kind of multimedia presentation, many slides. So I'm just taking a few, and then we kind of plotted this over time, right? So you have time on the x-axis, and then what we've done is we averaged, right? We average this measure of similarity for every year, and we plotted this on the y-axis, and you can see how in the 70s and 80s and till about maybe somewhere, maybe till about 90s, actually there is more diversity every year, and then maybe in the end of 90s suddenly things go up very much, and then things become more similar, and then we notice that in the last few years after 2014 there is a kind of opposite trend towards more diversity. So I'm very interested in this analysis, right? It's using a very simple idea of statistics, right? Variability and diversity to look at the evolution of diversity in art and fashion, in literature, and so on, right? So very interesting. And then this is another paper, just to give you different examples. So this is from lab of Laszlo Barabasi, who is the most well-known, most cited scientist in network science. And what we've done is that they, why it doesn't go? That's interesting. Just a moment. Strange. You know what I told you, what happens? I should have not, when I use full screen, I'm so sorry. When I use full screen, sometimes Keynote, something happens to it. And okay, maybe here, no, just a moment. I'm trying to go and nothing happens. Why? Maybe I have to restart and log in back. I'm guys,
Okay,
I'm sorry about it. Yeah, I'm not sure. It's like, I think it's a kind of bug with Keynote. That's why sometimes I don't do it in the play mode. I just kind of go for the slides, but I was hoping it will not happen. Okay, I'll be back in 30 seconds. I apologize. So.
Okay.
Yeah, I'm sorry about it. If I can even restart, I hope. Can I restart? Okay, sorry about it.
No problem. Take your time.
Yeah, I'm trying to restart.
So let's wait patiently. Lev will be come back in a minute. And also, like for the ones who just get in the room, I paste again the post here. So for after the section, if you have any further questions or other potential topics you want to talk about this section, you can also have your comments submitted through the links I pasted there in our chat box.
All right. Yeah, I'm very sorry about it. Very sorry about it. I think it's something to do with Keynote, because it kind of happens quite frequently. So let me continue, but I'm not going to put Keynote in a play mode.
No problem. No
So,
problem.
yeah, apologize. Well, it is a problem, but I like to be professional. But you know, anyway.
I understand. It happened to me yesterday in class too.
Also with Keynote, or yeah, but maybe I should use PowerPoint. You know, so maybe not being like a hipster. You know, so okay. Let me see. I hope I'm opening the right presentation. Okay. Oh, that's okay. That's here it is. Okay. Actually, anyway, yeah. So perfect. Yeah. So I'm not going to play mode. So this is a work from Professor Barabasi Lev. You know, we got the data for about 450,000 artists. So we claim it's kind of every artist who had some commercial exhibitions and commercial galleries and museums in the last 30 years. Actually, when I look at the data, I found that we don't have most Asian artists or Russian artists. So big data always contains some, you know, missing things, but the paper is very interesting nevertheless. So what we've done is we can quantify artist's career. So we build a network, right, where all the nodes are museums and galleries. So then we can represent each artist, right, as a kind of path for with different museums and galleries. And for this, purely by looking at the relationship inside this network, we quantified the importance, right, of you know, each museum or each gallery, kind of a bit like the web, depending on how many links, right, how many links go to this museum, right, and gallery. And what we found out is something very interesting. So we found out that people who had their first 5 exhibitions in the kind of highly prestigious places, they continue to have, you know, good career, and most of them, right, continued to exhibit in these high prestigious places, but for 60% and then for 40%, maybe a bit medium prestigious, but almost nobody, almost like once you kind of start exhibiting, right, in good top places, you're guaranteed to have art career, right? Almost nobody went down. Whereas people who had their first 5 exhibitions in what we call low prestige places, maybe some non-profit places or something else, very few of them, right, raised to the top. So this is again very interesting, very revealing, and you can do this kind of analysis, right, for all kinds of cultural data sets, all kinds of cultural questions. Okay, we'll skip this. Okay, we'll skip this. Right. But when we do this analysis, right, in the first case, we can aggregate, right, many songs, and we come up with an average measure of variability for each year. In the second case, right, we're not looking at what artists do, we're not looking at their artwork, we're simply looking at their career. So we're kind of dealing with metadata. And what I was interested is also do something else, which is to kind of observe and analyze contemporary global culture, but also looking at what happens inside the cultural artifacts. And when I started with very kind of utopian idea, but I try to start always with like a very big idea, which is impossible to reach, because if you set yourself, like a small idea, average idea, you're never going to go maybe get as far, so you will not get very far. But if you set up a utopian idea, you're going to jump higher, right? So I had this utopian idea, which is let's include all cultural objects, all events, all conversations taking place visible online, right? Everything, because why not, right? I mean, if you think about all the images people share today, Instagram and so on, or other types of cultural artifacts, it's a lot. But I think it's much simpler than trying to analyze a single human brain, which has 100, right, billion neurons. And the reason is that the culture has lots of, it has lots and lots of repetition, right? So very few cultural artifacts are truly original. Right? And this applies both to historical culture, whether it is ancient Chinese, Korean, Japanese, or European culture, and contemporary culture. Right? Our society is based on this need for originality. In reality, very few people are original. Right? Most people just kind of follow existing templates. They emulate each other, or they create works which use combinations of templates. So contemporary art is not any more creative than all of us who create presentations using existing templates, PowerPoints or Keynote, right? So there's lots of redundancy, right? So this implies that in fact it wouldn't take lots of computational power to analyze contemporary historical culture because there's lots of redundancy, right? And here comes actually interesting question, right? How much original information is being posted, right, or online every day? I mean, nobody asks these basic questions, right? I don't know why. I mean, people measure how much data is being created in terms of megabytes, right? But it's one thing to say, okay, how much data is created. It's another thing to ask how much of this data is original and how much is copies, right? So culture is redundant. And I took my inspiration from actually 3 different fields. One is scientometrics, right? So analysis of science based on citations. The second is evolutionary biology. And the third is geographical information systems. So geographical information systems, or GIS, I like the approach where we represent kind of reality, right? The spatial reality in terms of many different layers. And obviously layers aligned to coordinates. So I thought maybe we can overlay, representation of music and fashion and journals and manga and see if these things can correlate. Evolutionary biology, it gives us a better model for studying, let's say, culture and humanities, because humanities, contemporary academic humanities in Europe are born in the 19th century, which is a period obsessed with classification. and people don't have computers, and therefore we come up with very kind of simple categorical systems, right? So, for example, 19th century, people start looking at the, many cultures in terms of like early period, kind of like a classical gold period, and then some kind of decline, right? Like Middle Ages, Renaissance, Baroque, right? And also people start thinking about particularly unique characteristics of national culture, because 19th century in Europe is the rise of nationalism. So kind of very simple model. And evolutionary biology, because we use math and now we use computers, is not afraid of complexity. So we say there's probably around 100 million species of plants and animals on this planet, and we only mapped out maybe 10 million, but we know there's more, right? So why not use the same very nuanced approach to model both human beings, social groups, and also, right, cultural artifacts? Why do we always have to divide human beings into like few demographic categories, like gender, age group, income, education, so on, right? Each of us is just a bit unique or a lot unique, right, from everybody else. Why it's so hard to model, 8 billion people in terms of their uniqueness, in terms of their difference, as opposed to always put people in aggregates and then calculate statistics or do predictions with machine learning. So, okay, oh, sorry, okay. So this is some nice visualizations from last 15 years of scientometrics, right? So people measure how different scientific fields are connected by looking at citations, who cites who. These visualizations first started to appear around 2002. So here we see kind of which scientific fields talk to each other. You can see humanities are in the corner. We only talk a bit of social sciences, but inside, right, different fields really talk to each other, and we also see, of course, that life sciences are very big. Right? So this is kind of classical scientometrics. Even this is from 2011, I think, paper published in PLOS. So in this case, we got access to, right, one of the biggest scientific publisher, right, where people go and read right, tens of thousands of journals online. So we got access to the web data, and we said, okay, when one person logs on to this portal, what are the different articles he or she reads, and then we can connect with articles in the network, and we got a kind of different map, right? Somewhat different map with different connections, right, based on the different information. Right? You can imagine hypothetically applying the same approach to the study of culture, right? So let's say, I mean, I'm all for web privacy, so I'm not suggesting we do it unless people give us permission to do it. But let's say we have some people who give us permission to do it, we can kind of follow, right? Okay, today somebody listened to music, when the person watched some movies, when he did something else. We can also connect with cultural artifacts, right, into a kind of network, right, as opposed to using traditional distinctions. And then this is just a kind of close-up, right, of this visualization. So I was very, very inspired when I started to see these things in early 2000. I said, I would like to create the same apps for contemporary culture, put all the different fields, high culture, low culture, doesn't matter, and really think about connections in terms of like similar styles, similar strategies. So this works with montage, this works with collage, and so on and so forth, and go into lots of detail. So to do it, I realized that we can't really do it right on a regular PC. We need like a big screen to see all this. And I was very lucky because I was invited to start my lab inside the top research institute for a future of computing internet, called T2, which was at the University of California, San Diego. And we had top people working on future visualization systems. So we were inspired by this, and we started creating kind of imagined interfaces, right, for a kind of giant dashboards, which will collect information, right, from the web in real time, and then can give us with dashboards to follow cultural trends and cultural patterns in real time, right? So here we kind of put this layout on this visualization screen, right? But this is not a working system. This was simply our kind of proposal. And this was a kind of walls I had access to, right? Notice this is not a wall of TVs. It's a wall of, at that point, it was like 2K monitors. Now you can put 4K monitors. So it was 70 Apple 30-inch monitors connected to 16 PCs with a fast graphics card. So it's kind of systems which are still not available today, right? So it's not like one computer driving few monitors, but 16 computers, and we build special software. And then this is already 2009, 2010. So we got a grant and we built our own software, which allowed us to load maybe up to 10,000 images, right, on this wall of any size, and then sort, zoom, and visualize these images, creating timelines and so on, right? So the idea was to, and that was the key idea, right? So the idea was, I don't want to start with some existing categories. So I don't want to start with machine learning, to extract particular features. I kind of want to be able to look at these images, right? So just as when we work with data, right, we have this idea of exploratory data analysis, and we create visualizations which show us kind of patterns in the data, landscape in the data, and we use bar charts and pie charts and scatter plots, right? So I said, okay, why not use the same type of visualization for images, except we're not going to reduce images to points. We're actually going to make visualizations out of our original images, because the image is not a point, right? The image is a world. And by being able to see the actual images on this big wall, we'll be able to see much more and probably find all kinds of other patterns, which we'll miss if we immediately start taking these images or applying machine learning. Actually show you some examples. So here it is, where it's again 2011, so it's like almost 10 years ago. We are looking at this wall, and the image which we have loaded is a visualization of pages from manga books, right? Manga, don't have to explain to you what manga is, right? One of the most popular cultural forms. So it's 1 million pages of manga from about 800 most popular manga publications, right? This is the original image, but you can't really make sense of it on a small screen, but you can do it on this wall. And what we did is that it was very early, so I mean, that was kind of before, right? Before convolutional neural networks started to become popular. So I was simply extracting single features and then right? And then plotting the images like a scatter plot in terms of single features. So the feature on the x-axis is variance, and the feature on the y-axis is oh my God, forgot for a second, entropy, right? And this is the close-ups, right, from different parts of this kind of image cloud. So on the left, you have top part. So this is images which have very high, right, so high information content. So, right, so as we kind of, as you scan the image, it's hard to predict what's going to happen next. So these are the images which will not compress very well. So we have lots of detail, we have complex backgrounds, and it takes more work to make them. And then on the right, you have a kind of this part, the bottom part of this cloud, right? And this is image with high entropy, right? So very, very predictable, easy to compress because we consist from these big blocks of one tone, right? And then you load these images on these walls, and you can zoom, manipulate it, and ideally, you can kind of change visualization in real time, right? So then we started, right, to apply. So when you say, okay, Lev, but what are you going to see, right? What are the new things you're going to see when you start using these methods? Well, so what I saw here is that I expected that we'll get a kind of islands, right? We'll see some groupings, we'll see some clusters, we'll see manga in different styles. And in fact, manga does have different styles because this is only looking at two features. So we're not looking at iconography, we're not looking at content, only two features. But it was interesting that on the kind of vertical axis, which is entropy, right, we get complete continuity, right? From most kind of simplistic images to most complex images, And this led me to this idea that, we never look at really big cultural data sets, right? So if we look at really big cultural data set, right, maybe it is music or painting or something else, perhaps, we're not going to find particular styles or particular genres. We'll find a kind of continuity. And the continuity becomes visible, if you start visualizing, analyzing big data. And then this is a kind of PCA plot, right? So some of you know PCA, of course. Now we can use t-SNE. So PCA plot already using about 200 features extracted from a data set, which we created, which is 5,000 paintings by French impressionists. So they're organized by visual similarity. So I'm going to zoom in on kind of this part of the plot, where you see paintings of French impressionists, which we normally identify with impressionism, right? So we're really light. We show either outside of Paris or new modern spaces, right? We use lots of pure colors for shadows and so on. But surprisingly, you find out that if you put all the images, right, in the visualization, these paintings which we associate with impressionists, it's only maybe 25 or 30% of our whole, all the works we created, right? So that was another idea I had, right? Not only, let's say, group images by similarity, we explore them for visualizations, but also ideally not sample culture, right? But ideally include everything. And if you include everything in a particular context, you realize that the traditional knowledge, doesn't tell you the full story. And then we started to work with Instagram. In the beginning, as you know, Instagram was a very kind of minimal, right? A very structured medium. All the images were the same size, 512 by 512. All images were square, so that made them easy to visualize. So, so here we have visualizations which compare samples of 50,000 images shared within a few days in San Francisco, and so I can see, okay, and Tokyo. And here you can see how these methods can be also not very useful, right? So here the images are sorted by average hue, average color, and then saturation. And, this kind of two features, they really don't allow us, in this case, to see all the diversities of the images. So the colors are very similar. The only thing which we can see is that people don't seem to take lots of pictures of green, because the cities, right, don't have lots of nature, especially Tokyo, and people don't seem to take lots of pictures of the sky. So when I thought, okay, maybe instead of visualizing these images using 2 dimensions, maybe I can just do 1 dimension, maybe it'll be more useful. So here are the images of 2 cities. I can share it on Instagram. So 2000, that was 2013. And it's images taken for a few days in New York and in Tokyo. And all images are just kind of plotted, right, linearly, actually top to bottom and left to right. And these waves, which you see, they change from day to night, right? So the night on Instagram is never completely dark. So people share images of, kind of parties and places we want to travel and so on, right? And you can see how, in fact, people sharing more images of New York, because there are more waves, right? There are more waves, there are more days which fit within 50,000 images. And you can also see how images of New York perhaps have a bit more diversity. And this is a kind of close-ups of what you see. And this is, Tokyo, where people go after work, we go get food, there are particular colors of ramen. So it's almost like a new representation of society through the social media images. And it captures kind of variability or let's say, right, or less variability in human behavior, and you can compare different cities. And then maybe just show you one more thing. So that's the image, this the project we did in 2014, 15. So we decided to visualize big data about a single city. So the city we chose was New York, but instead of doing 2-dimensional map, I mean, there are all kinds of 2-dimensional maps. We decided to just take a single street, which is Broadway, right, which is longest street in Manhattan, 22 kilometers. And we collected about 40, yeah, I think just yeah, 40. I think 40 million, right? Yeah, 40 million data points for Broadway. And here you see kind of like bar plots. So the lower Manhattan is on the left and upper Manhattan is on the right. And this is some of the data sources we used: Instagram, Foursquare, Twitter, income data, taxi, and so on. And for example, if like you notice somewhere on the left, some bars are very high. That's for Times Square, because 14% of all Instagram images were shared in Times Square. But this is the kind of representation, right, most suitable for scientists. So we wanted to create something which normal people are going to relate to. So we created this new type of interface, which was exhibited in New York Public Library and other places, where we kind of made this like slices and sampled the actual images. And you'll see a little video of this, I think, in a second. Okay, no, just a moment. So what did happen? Just happened. Okay, here we go. So this is recorded from a screen. So you'll see these layers building up. And what happens, right? You can kind of zoom in, even the images expand, and you kind of travel along Broadway, kind of 30 meters at a time, because we used the images captured by Google Street View, right? And then you can kind of, again, using your gesture, right? You can condense it. Even you can see the whole 22 kilometers in one screen. And this points which you see in the middle, this is statistics, right? So it's average number of income and how many images people share on Twitter and Instagram and how many taxi rides people take. And this number also gets updated. So if you're zooming in, the number is the average for 30 meters. And if you zoom out, you get the average for the whole thing, right? So the idea was to create a kind of dynamic sampling, right? So I'm not against statistics. I'm not against aggregation. I'm not against summaries, but I don't want this to be used only as default, right? I want us to be able to use the computer abilities to zoom in, right, into kind of cultural and social data, into culture and society, and from the level of a single brushstroke, or the level of a single behavior of a single person, all the way to countries, centuries, and so on and so forth. And I will end with let me just find where it is. I will end with describing, right, what I see is this kind of big challenge. I mean, I think with visualizations and projects which we're creating in our lab, it was what's happening kind of before I realized exactly, right, these challenges, but maybe instinctively I was perhaps already moving towards these ideas. So I certainly can't claim that we'll be able to meet these challenges, but in some ways I think we did something right. So this is what I see as the perhaps main challenge in using computers to study culture, but also to study society. So the same things I can apply to computational social sciences. So what we know how to do is to use a statistical paradigm, which still drives data science as well. And the statistical paradigm, right, in a way, right, comes out from 18th and 19th century, the collection of kind of government statistics, economic statistics, right, to be able to see certain patterns, to be able to govern the country, right, or govern the industry. So you get lots of power from aggregation. And also, right, another place was, for example, astronomical observations in the 18th century, right? So you're trying to observe position of object in the sky, and every time you measure it, right, you get a point somewhere else. So when people realized in the 18th century, right, you have all these points, and if you derive average value, that's probably going to be the correct position of object, right? So in this case, aggregation, adding more and more cases and then averaging them was a very good method. But is this the right method to talk about cultural society, right? Think about great artists, Van Gogh, Picasso, Namjoon Pike, and so on. All these artists were outliers, right? So we use traditional kind of approach, we simply would throw them out because all our methods would simply not see them because we'll see kind of average tendencies. So that's how I define this challenge, right? So shall we aggregate big cultural data and reduce it to a small set of patterns, frequently occurring ideas, themes, styles, behaviors, Right? So, for example, I can follow, right, what happens on Instagram by perhaps reducing it to like 50 or even 30 types of images, types of photographic parameters, types of subjects, and I can do it, right? So this paradigm and the same thing, right? For example, Twitter automatically aggregates all the tweets in a particular geographic areas and says this is most popular topics, right? Now, this paradigm focuses on what is common between a number of objects and doesn't include what occurs infrequently. But of course, as we now understand, there is a danger in this paradigm. So in the case of industrial social media, right, people say, okay, this is popular. I'm going to look at this. And then I'm going to like it, right? And then what is being liked gets bigger and bigger. And there are other things, right, which are not exposed by the interfaces of social media platforms, and we get no attention, right? So, in the 20th century was the era of normal distribution, and our century so far has been the era of power laws, right? Where you have this very steep curve where few people get all the attention, and then many other people get completely invisible. So what's the alternative? Well, the alternative would be to try to think very differently, right? Refuse this kind of dominant paradigm and instead focus on diversity, variability, and differences, right? Not to think about objects in terms of what we share, but to think about objects in terms of how we're different from each other. And that's what I mean by this paradoxical, right, impossible sentence, work on big cultural data without aggregation. So it means we want to include everything. We don't want to throw anything away. And what we want to do is we want to identify what I would call small cultural islands, not necessarily single outliers, but a few people doing something happens in this area, a particular style evolves, which is kind of underground. And the problem with small cultural islands, they can disappear, right? If we just, for example, take Twitter, Instagram, or whatever, TikTok, and just do one big sample. So okay, we're going to sample, we're going to get a few million posts, and we're going to study them, right? And then we'll find some general characteristics, but maybe general characteristics only account for 20% or 30% of the content, and everything else disappears. And also, I want to question the idea of similarity, right? Where we use categories, we do cluster analysis, we use dimension reduction methods, and so on, right? We want to question the idea of similarity. And just one more example will finish. So here's a work from the last few years from Yale University. We have a digital humanities lab, and we have a collection of 27,000 historical photographs. And then we use like the early version of a convolutional neural network, all right, to learn some patterns in these images, and we created this kind of simple interface, right? So what you have is a kind of like type of PCA or UMAP visualization of all these images in terms of visual similarity, and then we highlighted the particular types like boxers, buildings, buttons, and then you can click on this image, and it takes you right to part of this kind of cloud where these images are clustered, right? So here we selected gowns, and we zoom in inside this kind of cloud where we see images of gowns. And the thing is, it may be useful, but it's also, I think, in a way harmful, right? Because all these images are unique, right? So when you kind of put all these images together, in a way, you prevent people from seeing what's different about them because you almost force them, almost artificially, into this category of gowns, right? And this is what I mean by this idea that can we build new type of interfaces, new types of data science tools, new types of thinking, which will ideally don't aggregate, don't assume that the world can be reduced to particular plots, particular deep structures, particular repeating patterns, but instead really try to understand, visualize, and map our contemporary and historical culture and also our society in terms of diversity, in terms of difference, as opposed to similarity. So I'm going to finish here, and I hope we'll have a few minutes for questions. Thank you so much.
Thank you very much for the very inspiring talk. So we have the Q&A section here. So feel free to ask Dr. Manovich any questions. Also, you can also type in the chat box if you want.
Yeah, so at first, ask a few questions. I think it's a really very interesting project. Actually, my group is work on data visualization. So what you show here, it seems quite relevant to us. So for example, we have one project also use the Google, street image, millions of image. We compare the New York City, Hong Kong, and also Singapore, for example, London, different city. And then we analyze this called human, skill forms. And something human can feel, just like landscape, grassland, building, vehicle, all these ones, how this kind of different city have different style. And also their Berkeley group is very interesting. They use this kind of, also use just image, then predict the crime rate. That means they analyze millions of image, and also there are some crime, report. Then you upload the image, I can tell you what is the chance, okay, your neighbor, okay, for this kind of crime rate. So for the question you ask, you raise, okay, this is a aggregation. Actually, our data science, we often say for big data, it's not about aggregation. Big data always about the long tail. And always say there's nothing new under the sun. So always kind of big picture already people discover. If you ask, any big data found some kind of, patterns in this very, large scale, which is surprise to people. I don't think so. But once you have all this kind of data for the long tail, always kind of long tail is hide the statistical curve. No one pay attention. For example, I will do data visualization. We have this called the data visualization mantra. That means you do overview first, you zoom and filter, then details on demand. This one allows you to zoom all the way to this kind of small data. For example, you present this one, you said how you can find this kind of some kind of very interesting, the individual, the items. So this one actually you can do aggregation, but you use a different metric. You can use entropy, you can encode, for example, how homogeneous that cluster is, encode the class quality, and then tell you, okay, oh, this kind of aggregation, how was their distribution? Then, okay, you zoom and filter, narrow down, and then can all the way do lead you to this kind of small item. So also their outlier detection and the salient figure, how you are different from your neighbor. So there are different ways to do this, but there may be having to integrate together all these kind of tools, whatever, having to integrate from the culture issue, the problem we want to study. So once these two combine together, many interesting things is buried onto this long tail will be discovered.
Well, thank you so much. And I think you presented the most coherent and, very elegant and short, but very rich summary of all the different methods. And I completely agree. And maybe the problem is that people only started to play with methods to a kind of cultural data rather recently, and they kind of just happy to get low-hanging fruit, so to speak, and they maybe perhaps haven't quite moved to study the long tail, right? Which is what's interesting. But I also want to say, how it is, how things are in computer science or data science, right? Somebody publishes a paper, even 10,000 people publish paper in the same area, but when other things people don't look at it. But I'll give you one example, right? What's interesting, right? People say, well, we have like big data and we have computer science, but we actually, sometimes we don't ask a very simple question, right? So for example, what's on Instagram? What are the different types of images on Instagram, right? In terms of content and visual characteristics. So there was one paper in 2014, they used like 2,000 images, a bit of like manual tagging, mechanical Turk, a bit of computer science. And we said, okay, we're going to come up with 10 most popular type of images on Instagram and how they correlated, etc. And after that, I don't know a single paper which said, let's look at 20, let's look at 30, right? So in a way, I completely agree with what you said, right? But I think even people can know these methods, but we don't sometimes use it, right? I mean, it's obviously a bit strange to me to reduce trillions of images to only 10 types, right? But I think it's the same thing, right? All the sociologists, right, try to aggregate society into a few categories of gender, age group, and so on. And we know why, right? Because partly, if you start creating more and more categories, data gets smaller and the patterns become less reliable. But in a way, it's a kind of, it's our challenge. I think it's our challenge, right? It's our challenge how to use our tools to see the world in a more precise and more nuanced way. And as you said, the tools exist, and we just have to apply them more, perhaps more frequently and not go for a kind of easy aggregation.
Yeah, I totally
and I want to say one thing. You know, you completely agree. But you know, I read like thousands of papers, and every single paper I know aggregates, right? Every single one aggregates. And then we get this. So people have these tools, but somehow we're not using them. So that's the challenge. How do we kind of actually start using it? That's maybe a difficult thing.
Yeah, still some way and make these tools, I mean, public available and easy to use to address the issue. But I agree with you. For example, I work on data visualization. You see, scatter plot is widely used, right? But even, I mean, many papers, I mean, studies, so whether people can perceive correlation from scatter plot, this is a very simple problem, right? You do statistical, correlation 0.7. Then I give you some visualization, whether people can perceive, okay, this correlation like 0.7, something like that. Even this is a simple question so far, and many researchers still no conclusion.
Well, I think visualization, I mean, the reason I kind of focused in our work on visualization as opposed to, because normally many people, what we do, right, we don't look at the data. So we're just going to immediately apply some statistical tests or et cetera, clusters, et cetera. So my idea was, let's visualize all the images, even though we're going to sort them by particular features, which is a kind of aggregation. By showing all the images, we're going to see more, because the image is not a point, the image is a kind of world, right? And what's interesting historically is that bar plot and the pie plot really developed in the end of 18th century, and the scatter plot doesn't appear until 1870s. So this idea, right? And I think the scatter plot, in a way, when you think about it, it's like a best tool we have to look at everything as opposed to reduce it. But most other visualization methods, it kind of presumes reductions of data, right? So I think, you know, the data visualization, we can still rely on ideas from 18th century in a way, in 19th century. And despite, right, as you know, decades of work, we still, I think we still kind of haven't gone very far. And we also don't know how to visualize media data, right? So what we try to do in a very, now, of course, everybody uses the same methods, but what we try to do is to, okay, let's take scatter plot and let's like expand it to include media. But then, of course, you still have problem of dimension reduction, right? Because in terms of similarity difference, the images can be different on 1,000 different parameters. And once we project into dimensional space, the differences disappear, right? So I think it's very exciting. I think very exciting, very important work, which can happen. And the last thing I want to say, there's also a problem that for the last 12 years, our interfaces for most people is this thing, right? And you definitely can't visualize all the diversity. How do you visualize, for example, all the different thousands of conversations happening in the forum, right? How do you visualize millions of people posting on Twitter at the same time? So this all gets reduced to a single column, right? So, you know, we don't, so Twitter or Facebook, we don't reduce it to some common, common numbers or common categories. We select, right? We select particular tweets, but we only select a few, and people don't say everything else, right? So I think the kind of interfaces we have to with social media, with social data, are also problematic, and that's why I think somebody has to work on this. Because otherwise, you know, as you know, right, you don't know what your friends are posting. So it's a very real problem. It's not just an academic problem.
Actually, I feel immediately, we have multiple, it's kind of a collaboration project, because you have the data, you look at this kind of problem in a very fresh way to us. And I have a 20 ongoing PhD work on all this kind of different visualization, all the issues you touched. Actually, we are working on that. So I think later I'll send you some papers. If you want to develop some new tools, whatever data analytics visualization, we can definitely help. This one I think is it's a topic very interesting, and the issues you raise, I think, is really to the point. So very good. So
looking forward to
we can continue the conversation for hours, but that's others.
Yeah. Okay. Let's maybe hours want to ask something. Yes. Thank you so much.
Yeah.
Thank you. So, any others have any questions?
Yes. Hi, Professor. Is that Manovich? Do I pronounce it right?
It doesn't matter. It's right. It's good enough.
Yeah. It's good enough. Yes. Okay. Yes. Oh, yeah. So I actually saw this seminar information online. So I'm not in the HKUST. So I'm like a prospective student who's want to like apply for the program. So I quite like your research about your research compare like the music genre between the music
Sorry,
in past.
this was not mine. This was by New York Times. Sorry.
Okay, okay. Yeah, so I quite like the research a lot. So
Okay.
I just want to like know more about the future about the data visualization. So for example, like because my background is coming from, so I'm studying marketing and information system at my undergraduate degree. So I'm quite interested into the intersection between like some implications of the data visualizations. And I saw like, so the future of the electric cars in China, especially like in the mainland, is quite big. And I saw like, especially like some very big car companies, for example, like BMW, they are producing like electric cars which have like big screens. So how do you see like the future of the data visualizations trend? Like how it's going to be evolved? You mentioned some implication, for example, like it can be used in marketing research and can be used in, for example, like different kinds of areas. And I just want to know like your idea about like how is the data visualization trend in the future? Like is that going to be like put that into the electric car, like in the big screens, and like how is that going to be evolved? Thank you.
Well, there is no way to answer this question very briefly. So let me try to reduce and aggregate all my ideas. So I have written about data visualization and also user visualization by artists. I am been teaching it for about 20 years. I'm in this community. Right, so basic techniques of data visualization have been invented, people say, right, in the end of the 18th century, and in around 1910, 1920s in the West, people start teaching it in classes. And when I think visualization really takes off, around 2006, 2007, because at this point, right, the web can display complex graphics, so PCs can display complex graphics, and kind of the development of web culture, just makes these tools available. But of course, today, every day, right, millions of people create PowerPoints, and they put bar plots, right, pie plots, sometimes line plots, maybe not scatter plots, because that's already too complicated for our audiences. So in a way, partly, right, I mean, there is amazing research in data visualization happening in computer science departments, and also designers and artists. But I think the long tail, right, of data visualization, because I say always people preparing presentations, they mostly use techniques which already were fully developed by early 19th century. So to me, it's a bit problematic because these techniques were developed before big data, right, before computers. So it seems to me that we have to develop some kind of new language, and maybe it will come. And again, I don't have an answer what these techniques will be, or which of the techniques already described in the last 20 years in computer science papers will become popular. But here's my hope, right? For me, this kind of device, which we used for the last 12, 13 years, it democratized access to information, but I think it also, in a way, limited our ideas. Because when people try to reduce everything to a small screen, right, obviously, you're not going to make very complex, three-dimensional, kind of very layered visualizations. I mean, you're going to see like little bars, right, which is what you see, for example, when you do financial applications. So now we're going to see in the next 10 years, this thing disappearing and found expanding, right, into some kind of roll or some kind of paper. So we're going to come back to what humanity always used, which is a very big screens. And once we have more real estate, right, I think people will start imagining, right, again, a more diverse ways to present information, and not only visualize data, but also how to visualize our conversations, right? I mentioned this idea. I mean, how do you make visible not only a few selected tweets from your friends, but everything what people are saying, right? How do you make visible, 20 billion conversations at the same time? And why not, right? I mean, it's an interesting challenge. So I think partly the kind of popularity of computers, and everybody has access to this, simple visualization tools, like Google Docs, and also the limited window of this device it in some ways was not, I think, very productive for human kind of visual imagination. And I think that, in the next decade, perhaps we'll see, and again, I don't mean computer science research, I mean the techniques which get adapted in society at large. I hope we'll see more work on visualization, but also I hope this kind of paradigms of a single stream, right? Twitter, Facebook, a single column. I hope we'll see something else, because frankly, I think we didn't do a very good job, right? So I think using recommendation systems and also using filtering and aggregation to only give you, few updates from all your friends, we didn't really meet the challenge of how to make big data visible and accessible by people, right? So there is very important work which somebody has to do. I hope students in this group.
Thank you,
Professor. In ours, our ability to generate data, conversations in media in the last 20 years has been so great. And our ability to create new kind of visual representations and interfaces to this data have really been behind. So today we have a big gap. And I think this is, to me, this is a very big problem, for technical but also cultural challenge.
Yeah, thank you. Thank you for your question also. Any other questions? We can take like one more questions from audience.
Hi, hi. Can you guys hear me?
Yeah.
Hi. I got a small question. First, thank you very much for the Lev. It's actually been very inspiring for me, and I'm quite excited about it. One question I would like to ask is, maybe it's kind of a too general question. I really like the phrase when you describe this age is the era of power loss. So do you think, in the future, the sort of traditional or sort of art training or in the field of contemporary art practice, do you think that would still exist like in the future, or like people should just, maybe forgot about the all the art practice, like people gonna be, let's say data science or something like that, like in that sort of sense, data scientist or something like that.
Well, so the title of my talk, right? It was of course not so serious. It was a bit ironic, but I basically borrowed this phrase from Alan Kay, who you should all know because his group at Xerox PARC in the first part of the 1970s invented modern computing, the overlapping windows, graphical user interface, and this is what made computers, usable by millions of people, and like many people who were like at the beginning, like Ted Nelson and others, he was a bit disappointed in what happened with commercial computing, and I don't know, maybe 15 or 20 years ago, he was giving these talks, which had provocative title, the computer revolution didn't happen yet. So I thought, okay, I'm going to borrow this phrase and be also a bit provocative and to say the data revolution didn't happen yet. And the reason Alan Kay was saying that 20 years ago is for him, he said computer is a medium because he was influenced by Marshall McLuhan. He said computer is a medium, and if you want to be, if you want to have literacy in a particular medium, you have to be able to read and to write. So he thought everybody who has using computer should also be able to program and kind of program their own media, not simply read outputs of our programs. And he was right, I think, and I think the same idea applies to our new kind of data society, where people need to have data literacy, and people who work with culture should have even bigger data literacy. So I think in the last 20 years or 30 years, those of us like me who work in digital arts, we're kind of promoting the idea that everybody should learn coding, everybody learn some programming, but that was before big data, right? So today, if I would offer some kind of like 1 semester, 2 semesters class, for any major, I would include something about how networks work, right? Clients and so on, how databases work, web programming, right? So the coding, the programming itself is no longer sufficient, right? Because it was sufficient when you can sit, write your programs on your PC. Right now, the computers connected to the web and to each other. So there is a certain kind of level of data literacy. I think people who actually work with culture should have even more than everybody else, right? So, I mean, I think it's happening. I think at least in America, I mean, many people in social sciences, many PhD students are learning data science, but I don't think it's happening that much in most countries. So the humanities is here, the arts is here, the science is here. It's still kind of conflict. I think it's still, people don't trust each other. This idea of art and science collaboration. So, again, there is still lots of things which should happen. I think it's also we and younger generations have to think about how to rethink university and schools curriculum, because everybody has to know about arts and everybody has to know about data science, because very kind of very important different types of cognition, right? And I think we need to have them both.
Yeah, thank you.
Well, I'm talking like a university president now. It sounds kind of cool.
It's interesting you mentioned something about trust in the art and science sort of collaboration. So I think it's really
you know what I mean, right? Yeah. Well, I think it's also because in many countries, especially in America, the scientists get this $1 million grants. So they're afraid that artists take their money when artists are kind of jealous of the scientists. So partly, it's very, very unequal distribution, and because arts are seen as like not really useful to society, whereas science is, and of course it makes it even more difficult for people to talk to each other. So.
Maybe artists should just try to get that funding stole from the scientists. That's one way they can get engaged.
No, don't say. Okay, that's you. Okay, let's. Well, we'll talk offline. We'll talk offline. Yeah.
Yeah, that's a good topic. Okay.
Well,
I think
I was like, when I started my lab, right? We learned how to apply for grants, and we gotten some very big grants, including from Singapore. But when I got so tired of like getting the grant and managing postdocs and writing reports, now I said, I'm not going to apply for any grants. I'll write my books. I'm sitting writing a few books, and there's also something nice about not having big grants. So
yeah,
it gives you more. It gives you but it gives you more mobility, because with scientists, they work so hard, right? It's like you have to get funding for your students. It's not necessarily so wonderful, but you get so much money. Money comes with responsibility. I think the computer science people in the audience can probably agree with me. So, yeah.
Thank you.
Thank you.
Thank you very much for today's very inspiring talk. I also very enjoyed the Q&A section as well. We presented a lot of different perspectives about the possibility in the future, as well as some of the art and science. So I'm very happy and very appreciated your coming to our seminar today. I'm also very looking forward for the future communication between you and our program.
I'm very open. I love to collaborate with people on projects. You don't even have to put my name in the paper, because for me, like, it doesn't make a difference. I like, I'm from Russia, right? I like collective. I like to work in groups. And also I like when people ask me about the future, because I didn't tell you about my newest project, a new book I'm working on, how to predict culture in 2050. So how we can use all these analytical tools and big data, not simply to study the present and the past, but to predict the future and future of culture. So I'm very glad that I was challenged to when people ask me about the future, and the future is bright if we make it so, right? So I hope that, this year will be a bit easier than last year. We can start traveling, and I hope, sometime soon to be able to visit your campus and meet many of you in person. And thank you for inviting me.
Thank you very much. Thank you everyone for joining this section, and also happy Chinese New Year. So thank you.
Yeah, thank you. Yeah, give you a big cloud. Okay,
All right, thank you.
Thank you.
Excuse me.